Okay, guys, so after today, what I've done is I have taken the questions from the question paper that we have been busy with. So these are the questions from November 2014, paper 2, question 7, the questions that we have been busy with. And what I've done is I've isolated just the questions that we need in order to deal with that last question that we kind of started with yesterday. So what I'm going to do is I'm going to show you the process that I go through in order to get to that final answer and calculate that final. And what I'm going to do then is I will also write out for you a step-by-step instruction as to how to do it. Okay, so you need to watch the video first and then have a look at the step-by-step instructions, and then I'm going to give you a second question. And again, what I'm going to do is I'm just going to isolate the questions that have to do with this last part of the question. Okay, I know this is tough, guys. Please don't think for 1 second that I think this is easy. I also know that it is in every single question paper. So we need to practice it. We need to have a systematic way of dealing with questions like these. Right. So I know a lot of this is familiar territory, but I want you to follow through with me so that the last part of the question that I know you guys are struggling with, so that you can get to that part of the question. Okay, so the question reads, a laboratory technician wants to determine the percentage purity of magnesium oxide. He dissolves a 4.5 gram sample of magnesium oxide, and he does so using 100 cubic centimeters of hydrochloric acid with a concentration of 2 moles per cubic decimeter. So this is going to be step 1, is to write down this chemical equation here. Now, if you roll down a little bit, they do give you that chemical equation. Someone pointed out today to me, ma'am, where did that 2 go? And when I had a relook, that 2 in this formula is actually incorrect. But having said that, in all of my working out here, because I'm only wanting to get to the percentage purity of the magnesium oxide, I almost end up completely ignoring the products, because the products here are secondary. They are not what we are thinking about. We only want to get to this final percentage purity of magnesium oxide. So the first thing I'm going to do is I'm going to write down this initial reaction. All right, so let's start there. Again, luckily this is given, so it makes our lives slightly easier. So we're going to have magnesium oxide, and it reacts with hydrochloric acid, and it forms magnesium chloride and water. Right, so that is the first reaction, and this is the first step. Now they give us the volume and concentration of the hydrochloric acid. And here in 7.2.1, they actually ask us to calculate the number of moles of hydrochloric acid here. So they're asking us to use the volume and the concentration and calculate number of moles. So I'm going to still do that because it is relevant to the entire big part of the question. So they give us the volume, which remember we need to convert to cubic decimeters. So I have to divide by 1,000. They give me that concentration, And now I use the formula C equals N over V. I substitute the 2 into C's place, and I substitute the 0,1 into V's place. And that means I now know that in 100 cubic centimeters of a 2 mole per cubic decimeter concentration, I have 0,2 moles of hydrochloric acid. Right. Now, guys, please remember that the hydrochloric acid is in excess. So the second reaction that happens with the hydrochloric acid, right? So the second reaction that we are going to deal with is where the hydrochloric acid that is left over after this reaction takes place, the hydrochloric acid that is left over is going to react. And that is where they get to in question 7.2.5. All right? They say that 21 cubic centimeters of a 0,2 mole per cubic decimeter sodium hydroxide solution neutralizes the excess hydrochloric acid, right? So first thing, we have to write down an equation that represents that. So the hydrochloric acid that is left over reacts with sodium hydroxide and it forms sodium chloride and water. Right. Now, we don't know how much hydrochloric acid is left over. But in the question, they tell us that we have a volume of 21 cubic centimeters. Again, we must convert to cubic decimeters. So I divide by 1,000. They give me a concentration of 0,2. Sorry, guys, you're going to have to deal with the puppies. They tell us that the concentration is 0,2 moles per cubic decimeter. And so again, we use the concentration formula and we can calculate how many moles reacted. Right, so I put the 0,2 here in C's place, and I put that 0,021 in V's place. If you guys remember earlier, when I did this in class, my maths were a bit suspect and I forgot about a 0. So that means that we added 0,042 moles of sodium hydroxide. This reaction here happens 1:1. So if there is 0,042 moles of sodium hydroxide, that means that there will be 0,0042 moles of hydrochloric acid. And guys, we need to remember what we are doing here. We are currently reacting the hydrochloric acid that is left over with sodium hydroxide. So once all the magnesium oxide has reacted with the hydrochloric acid, we know we have 0,0042 moles of hydrochloric acid left. We started with 0,2 moles. So if we started with 0,2 moles and we now calculated that we had 0,042 moles in excess, if we take the difference between the two, 58. That means that 0,1958 mole of hydrochloric acid reacted with the magnesium oxide. Right. I think you guys are okay-ish up until this point, right? So step 1 was to write down the reaction of what we are actually ending up wanting to get to. The second step is to calculate how many moles of this thing in excess we started with. Remember, they said to us right in the beginning, we've got 4,5 grams, but it is impure. So we cannot work with this 4,5 grams. We can, however, work with the hydrochloric acid. We know hydrochloric acid is in excess. We don't know by how much, but we can have this chemical reaction here where the excess hydrochloric acid reacts with a known amount of sodium hydroxide, and there we can calculate how much hydrochloric acid was in excess, and that then takes us back to the original reaction where we calculate how many moles of hydrochloric acid reacted in the first reaction. Okay, now we have to look at the ratios. Guys, if we write nothing in the front, we assume that it's a 1. So 1 mole of magnesium oxide reacts with 2 moles of hydrochloric acid. So if I need to know how many moles of magnesium oxide I started with, I divide the number of moles of hydrochloric acid that reacted by 2, because they react 1 to 1. And if memory serves, I think we got, I think, okay? Right. So now we know how many moles of magnesium oxide we started with. Now, and I know this sum gets long, we need to calculate what mass of magnesium oxide, pure magnesium oxide, we started with. We have moles. We can go and calculate molar mass. And then we can use this old formula that you guys learned in like grade 10. And we can substitute the moles of magnesium oxide and the molar mass of magnesium oxide. And now we can calculate how much of that mass was magnesium oxide. I'm going to go back and double check my calculations, but it looks like it's right. You never know with me. Times 40. Okay, so to get rid of this 40, I have to go 0,0979 times 40. And my calculator tells me that that is 3,916. So I'm going to go 2, but you could just leave it as this value. Okay, again, we need to interpret what are we calculating. Right, so this is the mass of pure magnesium oxide. We know that they added 4,5 grams, but it was impure. So of the 4,5 grams, only 3,92 grams is actually pure magnesium oxide. And now if we have to calculate percentage purity, we say we know that 3,92 grams was pure. The total sample size was 4,5, and we multiply by 100 to turn it into a percentage. So I get 87,02, 87,02% purity. Right, guys, I'm just going to talk you through the process again. Don't panic. I know this is hard. So the first thing you do is you write down a balanced equation for the original reaction. And if possible, you calculate the number of moles of the solution in excess. Then you write down an equation for when we react what is in excess. You'll notice that I don't take the magnesium oxide into the second reaction. I only take the reactant that was in excess to my second equation, and I react that with something else. Then they tell me volume and concentration of what I reacted with. So I can calculate the number of moles that was in excess. Now that I have the number of moles in excess, I can calculate the number of moles that reacted, which tells me how many moles of magnesium oxide I had, which I then take to mass of magnesium oxide, which I then take to the percentage purity. Right, guys, I'm going to write this out for you linearly, one behind the other, and I'm going to screenshot it for you with descriptions, okay? And then I want you to try the second problem. I'm going to screenshot that for you as well. I want you to try the second problem and see if you follow this process that I've now given you, whether or not you can get to the final. I know it's a lot. Please don't think for 1 second I don't realize how involved this question is. But it is going to be in a past paper, so I want you guys to really, really master the process that goes with this.